Last one. It's hard to follow after all those amazing bits of technology and great businesses, but very happy to be here. Question, has anyone in this room ever driven in a Bentley or owned a Bentley? Maybe. So we're going to take you back about 10 years. I'm there on a phone call with Dr. Winterkorn, the chairman of the Volkswagen Group. And he's saying, are we going to get the Bentley Flying Spur shipping? You know, every month this is held back, it's going to cost us, 10 million euros, I think it was. I'm there with my previous business, one of my previous businesses, saying, yeah, it's okay, don't worry, we'll get this working, we'll get manufacturing unblocked. And so what was the problem that caused this massive cost? Fundamentally, so this was the rear seat entertainment system in the Bentley Flying Spur, and the hardware was just too old to do what they needed it to do, right? And we had to do lots of nasty little tricks to get this working so it actually could, do the entertainment that they wanted it to do. And what really is going on there is every time, and I've worked with multiple multinationals building products across the last 20 years, and you're always there going, you start off with we're going to build this, you got your plans, and then you start discussing with all the chip manufacturers saying, okay, we need to be able to do this functionality, are you going to be able to support us? And they go, yeah, you need to wait for the next product, it's going to come out in a couple of years, you can hold on for that, and then you'll start building. And then you get the chips, and then you start writing the software. And before you know it, it's been 5 years when you get to the market with your product, and someone like Google or Apple, they've been pushing the envelope forward much faster than you've ever had a chance to, and so you're looking pretty shoddy. So, what is it that Google, Apple are able to do that Volkswagen Group isn't, right? And the main thing is they can build their own chips. They can be innovative, they can get lower build costs, and they get products out to the market much faster. And that's given by the volumes, really, at the end of the day. You're selling cars, you're happy to sell, 100 million cars a year. That's nothing in the smartphone business, right? So volume, what's the bill of materials you're trying to fit this into? Surprisingly, cars, there isn't, the bill of materials for cars is really small. And then can you hire and retain the skills, right? And automotive companies have hard enough times hiring and retaining software skills, never mind hardware design and chip design skills. So I should have been skipping on a little bit. So really the question came in, and I was there paying some attention to what was happening with the open source world in hardware, and the question really came in, can we help? What can we do? Is there something we can do now that wasn't possible before? So one of the things that we found is in the open source world, new technologies around chip design are starting to come together. And it looks like this is going to transform hardware building as much as it did the software ecosystem. And so using these technologies, we can now pull together a platform where you can use software engineers to build and design chips, get them working, get them manufactured, and get them in your products. And what that gives you is not only kind of a massive cost saving against if you are able to build chips, massive cost saving, but if you aren't able to build chips, massively faster time to market, and collaborate, being able to design exactly the right thing at exactly the right bill of material costs for your product, and being able to innovate. So if I think about this, so just give you a little comparison. If I say I come out and I go, okay, I'm building a new VR headset, I need some new capabilities. Shoot, nothing on the market can do what I want. Okay, I'll go and start writing up a spec. I'll go start talking to service providers in this space. Very quickly, you'll get to, what happens for a lot of people in this space is you very quickly get to a no, right? You don't have the volume. You've got your bill of materials is too low. And then even if you do meet all of those, you need to have the skills on your side, even just to integrate with the suppliers. And then the supplier is going to go say, well, we'll help you write a specification, we'll design a chip, and 2 years later you'll get a chip. I mean, that's not much use if you're in a rapidly moving, innovative environment. So with ChipFlow, what we've done is we're using some of these new technologies that are coming out of the open source world, putting that into a proprietary platform and allowing people to really massively reduce the time so what an organization can do is design exactly the right chip for exactly the product needs, get that manufactured and iterate on it and have iterative development experience driving their product needs forward. So as an overview of what happens here, so the key thing that really allows you to hire for this capability is that we allow people to write code with Python, to write hardware with Python. So you can do your chip design in Python, and a little later on I'll show you, for those that are technically aligned, I'll show you a little slide later with how that looks. Then with a bit of AI and a bit of smarts and a bit of understanding more about what we need, constraining what people need to do, we don't need to support every type of product on the market. We can then automate getting that out to the manufacturer, getting the chips made, getting the chips tested, and getting them integrated into the manufacturing supply chain of our customers. And realistically, what we're doing is we're doing the software side of that. This is a platform as a service. The hardware side is all partners, and we've got multiple partners already engaged. Everything from plastic electronics to silicon germanium to traditional analog and digital IP foundries. I think this is slightly different. So just to give you a little bit of overview of what's going on with in the semiconductor space and the amount of product that's utilizing new chip technology. This little graph here, going from 15 there up to 36 there, that is the number of products containing a semiconductor chip on the market. So is this a business? Right. We've got the technology, we can actually build this. What does it look like business-wise? So obviously there's a big market there. We're talking growth predictions about 1.2 trillion for the semiconductor market. But what can we actually do? So where we look at this is what we're doing is giving this capability to a new section of the market, right? So going from, if you want to consider making a chip, you've got to be at least a 200 million revenue operation today. Realistically, you're probably going to have to be a lot bigger than that. If we go, okay, we bring down the cost 10 times to design and manufacture chips, what class of organizations does that enable? And we can split that over consumer electronics, telecoms, automotive, industrial, aerospace and defense, and other, which includes things like hardware acceleration of quantum or cryptography, or I think I've had 3 companies come up to me today and go, can you help us build an accelerator? And look at that, overall in our model, ends up looking like 11 billion of recurring revenue if we can reach all of that marketplace. We have commercial traction at the moment. So we have an agreement in place with Pragmatic Semiconductor, which you may know is one of the novel semiconductor companies in the UK. So they're building plastic-based chips, very low cost, very high volume, covering areas like packaging and healthcare. And we've got an agreement there to help them get to their marketplace, right? Give the tools to their customers. We have agreements with IMEC, which is one of the major IC design, research, and implementation companies in Europe, very heavily connected with the EU Chips Act. We have late-stage sales at the moment, totaling about 400K, mostly kind of with the startup side. We've kind of a lot of people have been waiting to get the Series B or C done, but that's all starting to fall out now. And go-to-market discussions with Global Foundries, which is one of the major semiconductor foundries in the world. Like I said, we've got quite a bit of traction within Europe. We actually host a bunch of the discussion forums for progressing open source technologies in chip design in Europe, which is all fed into the EU Chips Act, which is a very long document, but if anyone reads it, there's some very interesting stuff around this space. If anyone techie, this is here. That's the definition of a Linux-capable system on a chip in Python. This little bit here says, and generate a Linux little boot on it. This over here, that's what a mask looks like. So the mask is what you send to the semiconductor foundry to go make the chips. And this little thing down here, that looks like Linux booting on it, all generated by that one piece of code and our platform. I've been very lucky. I've built this pretty much on sweat equity to date. So I've been very lucky to have an amazing team of people I've picked up in my 25 years of embedded systems and open source technologies, including Tommy, who built Harman's software the company that was bought to be Harman's software engineering teams. Thought leaders in the open source hardware space, and old school guys like Michael down here, who was actually part of the very first semiconductor tool team ever in 1986, and then went and did all of Sun's and Oracle's technologies. Again, more, these. Fortunately, one day I'll get Catherine to give me a photo, but she's actually the main thought leader in how you use Python to describe hardware, and the main communicators and thinkers in this space. And we're doing a really small raise. We're doing a 750K raise, and that's really to allow us to deliver against the commercial agreements that we already have in place, and get our beta platform out and released sort of mid-next year. That covers us for about a year's worth of engineering. And of course, we have expectations of revenues as well on top of that. And the grant funding. So yeah, and where that's coming from, that's just really our spend is engineering and the people that we've already got on the team. So that's it. Thank you very much, everybody.